Today I've got something quite special for you guys. Well, if we can save it, that is. In my quest of figuring out the last quote-unquote real Commodores, we've got this pretty rare Commodore 28616 on the bench today. I just checked and apparently this is a first on YouTube. It's not quite as rare as the Commodore 486 SX25, but definitely as good looking. Maybe even more so. It's quite apparent that whoever designed Amiga 4000 and the Commodore 486 SX25 also designed this gorgeous Commodore. But as so often on this channel, there is a small problem with this machine. If we can fix it, we'll do some overclocking too. Now let's pull that lid off and I'll show you what happened to this poor little Commodore. 286s are generally older than 486s. But this 286 runs at 16 MHz. And 286s that fast came quite late. I have not checked the dates in this machine yet. So that's the first thing we need to do. This chip here is made in week 2 of 1991. So this is actually a pretty old machine. And the same thing here with the 286 from AMD. It's a 16 MHz chip. So pretty damn fast 286. So it's older than I was hoping for. But still a very late 286. But it's manufactured several years earlier than the Commodore 486 SX25. By the way, Commodore started to licensing their products in 1994. So being manufactured in 1991, this is definitely a real Commodore. This Commodore actually looks quite minty inside. But let me show you what's underneath this graphics card here. You guessed it. We've got Varta from hell here. Look at that disgusting thing. It's just puking out that battery juice on the board. Nasty little Varta. I can definitely see some damage on the board here. And same thing over here too. These diodes here look pretty crusty. But this is nowhere near as bad as in the Commodore PC-10. So this definitely looks repairable. And here's something interesting for you. Apparently Commodore used a Sharpie to try to cover up that the board they used is a DTK. And here's the model number, PTM1661C, neat all-in-one. And apparently the BIOS is from an SL286 SX16. It's a very similar Commodore, but much smaller. So maybe they share motherboard. This board has 4 SIM slots and 12 RAM chips directly on the board. Riser has 3 16-bit ISA slots on this side and 2 8-bit slots on this side here with some empty pads. It has an international power supply from DataTech Enterprises Co. Ltd. And the hard drive is an ST157A. There is a sticker at the back here that tells us that this is a Type 17 hard drive. There's also this red sticker here that says 16 and 40. So presumably 16 megs, 40 meg hard drive. I guess we'll find out. And it has one of those funky diskette drives from Chinon that we also found in the Commodore PC-35. The design of the chassis is quite unusual. So I'm gonna have to do some guesswork here. I think we need to start with the hard drive. Because I can't access the screws to the diskette drive. Okay, and here comes the hard drive. Everything inside this machine looks mint. Well, except for that nasty Varta. The motherboard has a built-in drive controller. So I guess I would agree with that neat all-in-one name. So let's pull that riser next. And now we can access the screws for the diskette drive. Okay, let's pull that drive. Being a really fast 286, we are definitely going to install a CD-ROM drive here. Well, if we can save this board. We better take a look inside that weird drive, even if it doesn't need any cleaning. Let's pull that front panel off. I don't know if it has yellowed. I think this might be the original color. So these weird drives have the small PCB attached to them. We did some compatibility experiments with the drive in the PC-35, but I wasn't able to figure it out. So it's not entirely clear to me what this PCB does. The drive cover has a mild corrosion on it, which I find kind of weird. We better remove that cover and inspect this drive. Yeah, very strange. Corrosion on the inside of the cover too. But the rest of the drive is spotless. It looks brand new. How strange. We've got some electrolytics here, but they are not bulging or leaking. This drive apparently is manufactured by SEQURE. Well, the drive in the PC35 just worked. So let's hope this one does too. This machine doesn't feel cheap at all. It seems to be quite well built. The back here has been resprayed in black, and all the connectors are clearly marked at the back here. It has an AT style keyboard connector, PS2 connector for the mouse, one parallel port and two serial ports. Oh, can you see that nasty Varda through that hole? The almost spotless power supply has a sticker here, so no one has been inside here before. And I say almost spotless because there is actually a tiny amount of dust here. So the machine has been turned on and used, at least briefly. I'm not going to turn on the power supply before we have checked inside. And the usual disclaimer, please don't mess around inside power supplies. The caps inside here may be charged with mains voltage. Inside here everything looks good. No refuzz, nothing bulging or leaking. Tiny amount of dust on the fan. It's barely noticeable. So this power supply is ready for a test. Okay, let's pull that board out next and see if we can fix that Varda mess. I'm glad it's not worse than this, but at the same time I have learned over the years that it's not the worst looking boards that are the worst boards. So I'll keep my fingers crossed. Okay, I took a picture of the connectors in case they're not marked. Here comes the board. There are a couple of corroded spots underneath the board here. So the battery juice has leaked through the vias, unfortunately. Well, that sucks. I was hoping it wouldn't. And here's your beauty shot of the stupid Varda. That thing looks absolutely disgusting. Looks like battery vomit. Okay, let's see if we can fix this mess. Okay, little Varda. Time to leave. I'll add some fresh solder to the pads. They're behaving strangely, making bubbles. So is that caused by the battery juice? Now let's see if my small nozzle is large enough for these pads. Yeah, definitely is. This nasty little Varda is also glued to the PCB. Okay, and it's off the board. I better clean this mess up before we continue. Let's start by replacing these pin headers here and this jumper, because they are clearly damaged by the battery. That stupid Varda found its way inside one of the serial ports at the back here. Well, it clearly went this way, messed up these diodes, and somehow found its way inside this connector here. I added some fresh solder. Now we can remove it. Okay, well, perhaps you can't see it. There's some green nastiness inside the jumper, so we definitely need to replace it. There are a couple of corroded vias, so I'm just gonna clean that solder mask off so I can tin them. On this side of the board it doesn't get worse than this actually. Since this machine is so clean, I want to make it really neat. So I'm just going to grind the solder mask off the damaged traces and then use some flux to tin them. I'll put some solder on the tip and then tin the damaged trace and vias. It's a bit stubborn, so I'll reapply flux until it looks good. The only damaged trace I can see on this side of the board is this trace here. So I'll remove the solder mask and clean it with Flux and fresh solder. The legs on this chip look really crusty, so I'll clean them up too with some Flux. And this trace here, of course. I'll just go with a larger tip. Drag solder. That's ALS 245. The trace doesn't take any solder though, so I'll just redo this process a few times until everything is nice and shiny. Okay, the pins cleaned up eventually, so they are now nice and shiny again. This trace is fine too. This via, however, is completely gone. There is nothing left of it. So this chip leg here doesn't make any contact to this via anymore, because it's completely missing. So we need to replace it with a tiny wire. I'm going to push through the via and solder at both ends. Unfortunately, this is a lot worse than I thought. So here's that via on the other side of the board. And as you can see, the pad is completely gone here. The via is still inside the board, and it's probably still connected to a trace inside the board. But we don't really have much to solder that wire to on this side of the board. So I'm just gonna have to hope we're lucky. Or this board may actually be a shot. Well, all I can do is to add Flux and solder and just hope for the best. This board didn't look too bad, and yet I'm not sure we will be able to fix it now. If the vias are disconnected inside the board, this is going to be a really tough repair since we don't have the schematics. Wow, we just got extremely lucky. I checked the datasheet for the ALS 245. This is the enable pin. It needs to be set low to enable that chip. So that via is just connected to ground. So there is still a chance to save this board. We just need to route this trace here to ground. Well, the ugly way to fix this is to put a wire from this trace here and to the ground pin on that same chip. And yeah, sure enough, it's connected to ground. But this machine is in such nice condition. I want to make this as neat as possible. So I'm going to put a wire through that via from the back of the board. Actually, before we install that wire, let's install the new battery holder. That will give us something to connect our wire to. I'll add some fresh solder to these crusty pads. Oh wow, they are so badly corroded, they just won't take solder. Well, I'll reapply Flux and solder until I get these pads cleaned up. And then I'll remove the solder with the desoldering gun. And now we can solder the wire to the damaged trace. And now we can install the coin cell holder. I have replaced one of the legs with a diode, so the board won't charge the coin cell. I'm gonna have to be a bit quick here, so the diode doesn't get desoldered from the coin cell holder. I'll cut that bodge wire to size and solder it together with the coin cell holder to ground. This way that repair won't be visible from the other side of the board. Okay, so that trace is fixed now and the battery has been replaced. Now let's see if we can fix this mess here. I'll start by applying some vinegar, because I think this crusty mess here is a bit too much for Flux. The vinegar is going to neutralize the battery juice, but we can't leave it on for more than 1 minute, or perhaps even less, because then it will start eating away at the traces. I'll scrape some of that corrosion off. Yeah, I think that's enough, so I'll rinse this stuff off with some IPA. Well, it's already looking much nicer. Well, let's add some Flux and get all that corrosion off. I'll use a larger tip with tons of solder, and then I'll just reflow all of these components. Well, the solder on this component here just doesn't melt. It's so badly corroded. And same thing with this guy here. So I'll keep adding Flux. and reapply heat until they give up. The battery juice messed up the board a bit here, but it looks okay. And I can't see any breaks. So these guys are connected. This diode here is going to the battery pin here. I think this is the charging circuitry. So I'm probably never going to use it, and it's not likely that anyone in the future will either. Now let's not forget to replace those pin headers that we removed earlier. Okay, it's the next day. The board has been washed and is now nice and shiny. So, time for a test. I'll add a graphics card and a postcard. Oh, this doesn't look too good. It's too heavy for the riser. We better put something underneath and keep it at roughly 90 degrees. Okay, fingers crossed. Let's turn the power on. Okay, nothing blue in the power supply. That's always good. Now let's turn it on and see if it will post. Okay, power supply turned on. We've got voltages and we've got a garbled screen. Okay. Well, that's not great. Oh, that was just a bad connection. That was because the graphics card was at an angle, so it wasn't properly seated. Okay, the machine is posting. This is awesome. And it says Commodore SL286. It's not an SL286, but from what we saw on the stickers on the BIOS chips, they seem to share at least the BIOS. Then we've got Commodore Electronics Ltd and Phoenix Technologies. Okay, cool. So I'll fetch a keyboard. Okay, keyboard connected, the original hard drive, the diskette drive with a DOS diskette in the drive. So let's do a proper test. Okay, hard drive spun up and it sounds good. Invalid configuration information. F2 for setup. Clock chip lost power, CMOS checksum, invalid, incorrect configuration data. Setup will automatically correct these errors. Okay, why not? What the heck is this? Page up for CS8221 options. What the heck is that? Oh, I see, we've got tons of more settings in here. We'll get back to this later. Slightly annoying BIOS, you can't type in the time and date. You have to use the arrow keys. Okay, diskette drive A. Well, I think it's a high density drive, but I didn't actually check. Hard drive is set to type 2, but according to the sticker at the back, it should be type 17. That's a 40 meg drive, but we only have 512K of base memory. I can't change the extended memory, so maybe that's what we have on the motherboard. We'll check later, of course, and try to upgrade. Graphics are set to CGA, so let's change to VGA. CPU speed low. I'm gonna go with high. I don't want to waste those 16 MHz. Okay, let's start with this and save. Now let's see if it will boot from the diskette drive. Yes, it does. Sweet, so we've got a working diskette drive. Pull that diskette out and reboot. And the hard drive is making some sweet vintage noises. And it boots to DOS. Awesome, so we've got a working hard drive too. What have we got on here? MS-DOS 401. Well, we're trying to use this crappy version of DOS in the Commodore PC35 project, and that didn't go too well. So I'll check that hard drive off camera to see if there are any fun games on it, and then I'll make a clean install. I'll see if I can find the factory restore diskettes. And unfortunately no, just the usual stuff. No interesting games on this hard drive. Well, I've had nothing but trouble with DOS 4, but if I can find a copy of the OEM version for this machine, I will give it one last chance. But for now I just installed the vanilla DOS 622 from 1.44 meg diskettes. So that drive is indeed a high density drive. And apparently we're running at 8 MHz. So we need to mess around with the turbo switch. I'll just install the jumper on the pin headers for turbo and hit F9. We're still running at 8 megahertz. Huh, that's strange. So this must be set in BIOS. There might also be some hotkeys to change the speed, like in the Commodore PC-10. But I've not read the manual for this machine yet. Well, I'm trying to find the key to enter BIOS. So I had a look online, and apparently the motherboard for the SL28616 is quite different. So apparently they don't share motherboard. But I also found this page here on the RetroWeb. This is for the DTK PTM 1261C. And according to this page here, it's also known as the DTK PTM 1661C. And that's the board we have. And the Commodore SL286. So was the Commodore SL286 shipped with two different motherboards? Something here is a bit unclear. Well, I guess I could try to find one of those machines and restore it. And then we will know. Wow, this took a while to figure out. I managed to find a manual. I would never have guessed how to enter the BIOS on this machine. So you have to wait for the machine to boot. And when the machine is up and running, you have to type Ctrl-Alt-S. And that enters the BIOS. Okay, let's see if we can figure out the weird speed we have on this board. And apparently we have a new error. Incorrect configuration data in CMOS. Memory size invalid. Okay, and it now changed from 512K to 640K. And the CPU speed is already set to high. So I don't understand why it's running at 8 MHz. Let's save and exit. It doesn't actually have a save option. So I'm just assuming that it's saving with F10. Like a more modern BIOS. Let's run Landmark again. Oh, now it's running at 16. How weird. That is bizarre. I didn't change anything. I just went into BIOS and saved. Let's pull that turbo jumper. Yeah, and it dropped down to 8. Let's run Superscape before we continue. This is gonna be slow. Really slow. We'll probably have lunch while I wait. We're getting a score of 4.2. Well, in that case, let's install a 20 MHz Harris. This chip is untested. So let's boot the machine and make sure everything is okay. Yeah, totally works. Well, this is a really fast 286. But you guys know me. I want to know if it can go even faster. So let's put this crystal in the socket. I'm gonna use the same method as we did with the P70 project. And just remove some of the pins in a regular socket. And now we can use it as a crystal socket instead. I did a quick test with the original crystal and everything worked okay. So let's install a 40 MHz crystal. Okay, fingers crossed. Oh, it's posting! Come on, little Commodore, you can do it! Wow, it boots! Holy cow! Let's see if it's stable too. Check this out. We're running at 20 MHz. Performs like a 22 MHz AT. Wow, this fast Commodore is now even faster. Let's run Superscape and see if it's stable with some heavier graphics. I'm not sure what benchmarks are the best for 286s and 386s. Maybe there's a better option than Superscape. Okay, almost finished. We're getting 5.3. Isn't this roughly what we got with the P70 project? I think it is, and that machine has a 386. Well, the graphics card that came with this machine is known to be really slow. So let's install an ET4000 and see if these benchmarks are affected by the VGA performance. Oh, we actually scored an extra point in Landmark. So it now performs as a 23 MHz AT. Okay, here goes. Almost finished. Come on, ET4000. Let's beat that score. Yes, it did. 5.8. So the fast Canon 286 has finally been beaten. Poor little Canon. I'll see what I can do. I guess we could try to make it faster too. Well, I was just about to show off this fast Commodore. I ran into a small problem. I tried to install Indy 256 from a diskette, but it refuses to copy the files. So first I thought the drive was shot. So I connected another drive, but I got the same problem. So then I figured my copy was bad. So I tried to make a fresh copy on my modern rig. Turns out this Commodore came with an ancient virus. So what this damn thing here does is to make a copy on the boot sector on any floppy you install in the drive. And occasionally it renders the diskette useless. But in most cases you wouldn't even notice that damn thing. It's easy to clean the diskette using Windows 10 or 11. Well, the hard drive is a bit trickier. Let's start from a DOS diskette. And try fdisk mbr. Okay, I cleaned the diskette in Windows Defender and made a fresh copy of Indy 256. Okay, let's try to copy the files to the hard drive. And it works, so we probably fixed it. But if we still have the virus on the hard drive, it's now making a copy on the boot sector on the diskette. So I'll check it in Windows Defender. No, it's still clean. So I think that fixed it. By the way, now that the system runs at 20 MHz, the turbo switch drops the system down to 10 instead of 8. So with this overclock, the turbo switch turns the system down to a pretty normal AT. The red sticker at the back implies that this Commodore once had 16 megs of RAM, which is an absolutely crazy amount of RAM for a 286. The only way to find out, I guess, is to install sims in all those slots and see if we can make it work. Well, this is now a really fast 286, but I wonder if it can go even faster. I'll order some stuff and make an upgrade video with more overclocking. When it's done, I'll put a link on the screen shortly. If you're watching this fresh, hit the bell icon below and set it to all. Meanwhile, check out this video. I'll end by saying thank you to my patrons. I appreciate your support. If you want to support me too, consider becoming a patron. Patrons get ad-free early access. If you like this video, let me know with a thumbs up in the comments. If you're a regular viewer, consider subscribing to this channel. Thank you for watching. I'll see you next week.